I'm Melissa Reynolds from Colorado State University, and I'm in the Department of Chemistry in the College of Natural Sciences, as well as the School of Biomedical Engineering in the College of Engineering. And my research interest, especially in the biomedical arena, actually started back when I was an undergraduate at Washington State University, and I looked at two different things. One, the synthesis of Taxol, which is an anti-cancer drug, as most of you know, as well as studying neurotransmitters within the brain. That kind of launched me then to want to go to grad school in biomaterials, which I did at the University of Michigan. Since then, and a lot of that work that I developed there was really working at trying to make devices that you would implant in the body more biocompatible. And so there was a lot to continue to learn in that frame. And I had spent a little bit of time in industry, in the medical device industry, starting to look at some of these problems. And in my tenure in doing that, what I learned is that, and what I really missed, is that I liked the interaction with both students and the other people that I worked with. And so kind of taking the more non-traditional path, I would say, well, I really want to go back into academics and study some of these problems that we have yet to resolve. And that is that if you put a device inside the body, so anybody that has a device inside of you right now, the issue remains is that sometimes things can happen, such as clotting, as the person before me had talked about, and so forth, that leads to serious complications down the road. And the problem is that the body is good because it makes these things so the body can control it. It's bad because we have to come up with other ways to kind of do this more effectively. And the cool thing is that nature already kind of designs this in for us right now. So our bodies release a molecule called nitric oxide, and it's what our blood vessels release naturally. And it's actually responsible for our blood not clotting, as you and I are sitting in this room today and having all of these activities. And so what we want to try to look at in our lab is trying to make artificial materials that actually can release nitric oxide at the same levels that our bodies do naturally as a natural therapeutic for overcoming some of these device failures that we see a lot, that aids actually dramatically into healthcare costs in the United States today. Just as a quick example, it's estimated by the American Heart Association that in 2010, the cardiovascular disease market will cost somewhere about $503 billion in 2010 alone in the United States. So there's a great need to try to develop materials that can be more biocompatible. And so thanks to the Boettcher Foundation and the web warning groups, we can look and say, well, how can this nitric oxide compound that our body releases naturally be incorporated into devices to help maintain biocompatibility for a long period of time. And so on behalf not only of myself, but as my students who are actually going to be supported in doing this work, we truly thank you and the people that went into making this decision, because as we heard this morning, 100 people or applications came through, so we recognize everybody's working time in trying to put that together. So again, I thank the foundations as well as CSU for the opportunity to do this research.